Software tools provide immediate utility. True architectures build compounding exponential moats over time. The first 90 days of a deployment measure utility. The next 2 years measure architectural output. This distinction governs performance in multi-node environments, such as automotive retail groups operating dozens of physical rooftops. Large organizations face a specific tension. They must scale systemic insights across disparate locations without creating an unnormalized data swamp. We resolve this through a federated data architecture, a structure designed to balance local autonomy with global pattern recognition. This architectural shift allows an enterprise to build an operational advantage that cannot be purchased off the shelf. Start at the foundation, a single isolated physical rooftop. Inside, discrete systems run in isolation. DMS records deals, CRM manages leads, and telephony tracks calls, generating unconnected data points. To capture this, we establish a local data lake, pooling these points into a single contained node. This creates data sovereignty. A location's data remains permanently inside its origin node. Sovereignty allows local teams to customize systems for their specific market and maintain strict regulatory compliance without interference. By isolating data at the local level, the enterprise avoids the tangled monolithic data structures that often stall traditional IT deployments. We separate local plumbing from the integration blueprint, the reusable logic. As expansion adds a second, third, and fourth rooftop, this blueprint is inherited. With logic pre-solved, new plumbing executes rapidly without friction. Consequently, the deployment cost curve bends sharply downward with each successive node. Deploying a workflow at rooftop 5 costs less than the initial execution at rooftop 1. This creates a cost flywheel, where the architecture generates a compounding financial advantage as the physical footprint grows. Inside a single localized lake, we can observe specific data behaviors. Siloed systems have inherent limitations. A CRM understands leads, but it cannot see the repair orders managed by a service platform. To bridge this, AI agents perform cross-indexing, actively mapping relationships between these disjointed systems. An agent might link a missed call to a specific marketing touchpoint, then connect both to a service visit that occurred 4 months later. Operators use these constellations to generate localized insights that were previously hidden. While valuable, these insights remain physically trapped inside the data lake of this specific location. Cross-indexing effectively resolves local blindness at the store level, but without a higher layer, the enterprise remains a collection of isolated, if intelligent, islands. Viewing the entire architecture reveals dozens of these highly functional, isolated data lakes. Above them, we introduce the Knowledge Hub. Crucially, the hub does not merge the lakes. It reads across them, using discrete, lightweight connections to view into each separate, unmerged lake. The hub translates locally customized data into a standardized KPI ontology. This identifies macroscopic patterns that are mathematically invisible at the single store level. For example, a specific sales objection pattern might be tied to a recurring trade-in scenario that causes deal failures. This scenario happens too infrequently at one store to be noticed, but across 30 stores, the pattern is glaringly obvious. These cross-rooftop correlations only exist because the overarching layer reads the network comprehensively. Federated normalization preserves essential local context while standardizing network-wide correlations, entirely avoiding the heavy friction and collapse inherent in centralized data monoliths. This architecture converts technical structure into a strategic asset: time. When a cross-indexed insight surfaces at one node, it feeds into the Knowledge Hub. The hub normalizes that insight and propagates it as operational coaching to every other node in the network. Every month deepens the local pattern libraries and sharpens the network-wide view simultaneously. A competitor starting this process 2 years later faces an insurmountable gap. Capital cannot compress operational learning time. A late competitor can purchase software, but they cannot purchase a 2-year head start on network-wide pattern recognition. The architectural moat is built one workflow at a time. The clock is the only non-negotiable input. Start it.